I am Nisha, Assistant Professor in the Department of Computer Science and Engineering. The topic which I am going to discuss today is design for human-computer interaction. Design for human-computer interaction is achieving goals within constraints. What is goals? Goals or purpose. Goal is what is the purpose of the design we are intending to produce, who is it for, why do they want it. Next comes the constraints. Constraints are materials. That is what materials must be used, what standards must be adapted, how much can it cost, how much time do we have to develop it, are there any health and safety issues. So these things has to be considered, that is materials and platforms to be considered while designing. And we should also look onto the trade-offs that is being involved in design for human computer interaction. The golden rule of design is we have to understand the materials, understand your materials. So what materials has to be understood? The first one is understand the computers that is being involved in human computer interaction. What are the limitations, what are the capacities, the tools and the platforms with which computers are involved. And next, understand people. The various psychological aspects, social aspects and human error of people has to be understood. And the way in which the human and the computer interact should also be considered. Next, the process of design. Designing is an important phase because based on the requirement, the designing will be started. The simplified view of four main phases plus an iteration loop is focused on the design of interaction. The first one is what is wanted. That is obtained through interviews and ethnography. That is what is there and what is wanted. Second step is analysis. The scenarios and the task has to be analyzed. After that, design has to be done based on some guidelines and principles. This design is based on some prototype, that is it has to be evaluated using some heuristics. Finally, a precise specification is implemented and deployed, and finally an architectural or documentation is implemented. The various steps in the process of design are: the first one is requirements. The first stage is establishing what exactly is needed, and this is usually necessary to find out what is currently happening. There are a number of techniques used for this human computer interaction, that is interviewing people, video tapping them, looking at the documents and objects that they work with, observing them directly. And the second one is analysis. The results of observation and interview need to be ordered in some way to bring out some key issues and communicate with later stages of design. In this analysis, we have to look at the scenarios, the stories of interaction, which can be used in conjunction with a method like task analysis or on their own to record and make some actual interaction. These techniques can be used both to represent the situation as it is and also the desired situation. The third one is design, and it is the central stage. There are numerous rules, guidelines, and design principles to be followed here. That is how to design, taking into account many different kinds of user. We need to record our design choices in some way, and there are various notations and methods to do this, including those used to record the existing situation. Some simple notations for designing navigation within a system and some basic heuristics to guide the design of that navigation should be considered. It is at this stage where input from theoretical work is more helpful, including cognitive models, organizational issues, and understanding communication. The fourth stage is iteration and prototyping. And humans are complex, and we cannot expect that design will be very right at the first time. We therefore need to evaluate the design to see how well it is working and where there can be improvements. Some forms of evaluation can be done using the design on paper, but it is hard to get real feedback without trying it out. Most user interfaces design therefore involves some form of prototyping, producing early versions of systems to try out with real users. The last one is implementation and deployment. This is the final step, and with our design, we need to create it and deploy it. This will involve writing code or making hardware, writing documentation and manuals, and everything that goes into a real system that can be given to others. So now looking on to the detailed explanation of iterating and prototyping. All interaction design includes some form of iteration of ideas. This often starts early on with paper designs and storyboards being demonstrated to colleagues and potential users. Later in the design process, one might use some mock-ups of physical devices or tools, such as you can use some shockwave or Visual Basic to create prototype versions of software. Any of these prototypes, whether paper-based or running software, can then be evaluated to see whether they are acceptable and where there is room for improvement. And this sort of evaluation intended to improve designs is called formative evaluation. This is in contrast to summative evaluation. And this is performed at the end to verify whether the product is good enough. And one approach is to get an expert to use a set of guidelines, that is knowing where you are, and we have to list everything and then look onto the screen to see if there are any violations. And the result of evaluating the system will usually be a list of faults or problems, and this is followed by a redesign exercise, which is then prototyped and evaluated. So iteration and prototyping are the universally acceptable best practice approach for interaction design for success. So you have to go with the redesigning in order to get a good design. And the next one is HCI in the software process. One of the distinguishing characteristics of any engineering discipline is that it has the structured application of scientific techniques to the development of some product. The software lifecycle is an attempt to identify the activities that occur in software development. In the development of a software product, we could consider two main things. One is the customer who requires the use of the product, and next the designer who must provide the product. So here the software life cycle should also consider the usability engineering, the iterative design and prototyping, and finally the design rationale. So the software life cycle, it is the discipline for understanding the software design process or life cycle. The designing for usability occurs at all stages of life cycle and not as a single isolated activity. So these are the activities in the life cycle. A more detailed description of the life cycle activities is shown in this diagram. The graphical representation is like a waterfall in which each activity naturally leads to the next. The first one is requirement specification. In requirement specification, the designer and customer try to capture a description of what the system will be expected to provide. This is in contrast of determining how the system will provide the expected services and for later activities how it can be implemented. Requirement specification involves information from the customer about the work environment or domain in which the final product will function. Requirement specification begins at the start of the product development. Through the requirements, the customers finds the requirement perspective. If they are to be met by the software product, they must be formulated in a language suitable for implementation. And these requirements are usually initially expressed in the native language of the customer. The executable languages for software are less natural, and they are more closely related to a mathematical language in which each term in the language has a precise interpretation or semantics. The second one is the architectural design. These activities concentrate on how the system provides the services expected from it. The first activity is a high-level decomposition of the system into components that can either be brought in from existing software products or be developed from scratch independently. An architectural design performs this decomposition. It is not only concerned with the functional decomposition of the system, determining which components provide which services. The next one is the detailed design. The architectural design provides a decomposition of the system description that allows some isolated development of separate components which will later be integrated. The detailed design is a refinement of the component description provided by the architectural design. The behavior that is being implied by the high level description must be preserved in the more detailed description. And the next one is coding and testing. The detailed design for the component of the system should be in such a form that it is possible to implement it in some executable programming language. That is, after coding, the component can be tested to verify that it performs correctly according to some test criteria that were determined in earlier activities. The next one is integration and testing. Once enough components have been implemented and individually tested, they must be integrated. Therefore, testing is done to ensure correct behavior and acceptable use of any shared resources. The last one is operation and maintenance. After product release, all work on the system is considered under the category of maintenance until sometime as a new version of the product demands a total redesign or the product is phased out entirely. So based on these are the activities in the life cycle as I mentioned before. Now verification and validation is the next step. In life cycle, the design must be checked to ensure that it both satisfies the high level requirements agreed with the customer, and it is also complete and internally consistent. It should also checks and it is referred as validation and verification, and it provides a useful distinction between these two, that is characterizing validation as designing the right thing and verification as designing the thing right. That is the difference between validation and verification. Validation is designing the right thing and verification is designing the thing right. So various languages are used throughout design, ranging from informal natural language to very precise and formal mathematical languages. And the formality gap, that is validation, will always rely to some extent on subjective means of proof. The management and contractual issues like design in commercial and legal context has to be addressed. This is the life cycle for interactive system, and we cannot assume a linear sequence of activities as in the waterfall model, and it will for interactive system it will get lot of feedbacks. The expert will have knowledge from a cognitive or psychological thing, and it will get the feedback, and that has to be refined. Thank you.